Well, folks, as you can see, I finally have some batteries put together, and I'm doing a light test run on them with our KitchenAid mixer. Anyway, it's a fairly light load. I don't know exactly how much. I'll probably check that and put that in the description. I put a little water in the bowl just for a little bit of resistance. Don't know if that does anything or not. Anyway, so what I've got right here is I've got 4 packs of 40 18650 cells, and the packs are put together with the fairly standard plastic cell holders. You can see right there, you got these little tabs that clip together. And to carry the main current, I went thicker than I'd need to, because I'm planning to add on to these to at least increase their size by 50 to 100%, so possibly double this pack. And I want to be able to solder a bar extension on right here and be able to carry all the current up through without a problem. This right here is 3 strands of 212 household wiring. I just took about 10 foot of it, stripped the plastic coating off, tied it one end to a solid point, and put the other end in my drill chuck and just twisted it. So I've got them set up in parallels, and it's nothing fancy, but I've just got a solder joint here, here, and right here. You know what? It does great for what I need for right now. Now, each one of these batteries is connected to the main bus bar by this little wire here. Now you can see right here it connects these two. That's completely unnecessary, but those two are connected through the bus bar anyway, and it was just simpler and faster to just come up, attach here, loop over, drop down, over, up, over, etc. Basically, I just zigzagged my way up through there. Converting this into AC, I've got, I don't know if you can read the display, there we go. We're running 15.2 volts right now, and that is not maxed out. It is at 0% power output, however that figures. Just trying to decide whether or not it's 15.2 or 15.3. Here I have my toaster. I did run that. It will actually run it, surprisingly enough. It puts a load on it, so you can see it sends it straight to 100% usage. I'm going to switch off the mixer, and it drops the voltage fairly significantly under that heavy load. Anyway, I'm not sure how much that's pulling, so I'm going to stop it and go back to that thing. So we'll see how well it works and how long it lasts. These little fuses, by the way, for anyone that doesn't know, these wires are fuse wires. What that means is they'll carry between 2 to up to 4 amps for a short amount of time, but if they get hit with a surge of current, they will heat up and melt and disconnect the circuit. For example, if this battery were to go bad, short circuit internally or something like that, the power from the rest of the pack would actually blow this wire right here, and it would take itself out of the pack. The only thing is, this pack would go out of balance quicker and that cell would need replaced. But it's a safety feature. So there you have it. This is my late night madness testing experience. I had been working, well, part of last night and a good bit of today to try to get this battery pack voltage down low enough so that my inverter would actually accept it. The inverter wouldn't accept it until the voltage was down to a total of 15.46 volts. Well, when I first put the battery together, it was reading 16.9, which had came out to, I think, about 4.12 volts. But don't quote me on that. It was last night and I was tired. So anyway, there you have it. Have a good one, folks. Bye.